हेलो नमस्कार दोस्तों. टुडे वी डिस्कस कंडेंसर्स, कूलिंग टावर्स एंड कूलिंग पॉन्ड्स. दोस्तों, in the starting of the lectures when we start this unit thermal power plant, we discuss the need of condensers, cooling towers and cooling ponds. Friends, condensers, cooling tower, cooling ponds are used to cool the condensate, cool the water, cool the wet steam, so that they can be used again and again. Friends, all the slides which we will discuss here are taken from the internet, especially from the slideshare.net, and the sole purpose of using these slides are only to educate our beloved students. There is no commercial purpose for using these slides. Friends, I am Dr. Tarun Gupta, Associate Professor, Department of Mechanical Engineering, GL Bajaj Institute of Technology and Management, Greater Noida. दोस्तों, जैसा आप जानते हैं कि हमारी यूनिवर्सिटी जो है KTU लखनऊ है, और KTU लखनऊ ने जो हमें थर्मल पावर प्लांट का सिलेबस दिया हुआ है, उसमें ये टॉपिक अगर आप देखेंगे कंडेंसर, कूलिंग टावर्स एंड कूलिंग पॉन्ड्स. सो इन्हीं टॉपिक्स को आज हम डिस्कस करेंगे. सो इन दिस केस वी डिस्कस स्टीम कंडेंसर्स. क्या स्टीम कंडेंसर्स क्या होते हैं, कैसे वर्क करते हैं, कितने टाइप्स के होते हैं, ये सब चीज़ हम लोग यहाँ पर डिस्कस करेंगे. सो फ्रेंड्स, फर्स्ट ऑफ ऑल वी डिस्कस द डेफिनेशन ऑफ स्टीम कंडेंसर्स. स्टीम कंडेंसर्स, और यू कैन से कंडेंसर इज अ डिवाइस इन विच steam is condensed to water at a pressure less than atmosphere. Friends, atmospheric pressure is 1.01325 bar. So the pressure inside the condenser must be less than this pressure. Condensation can be done by removing heat from exhaust steam using circulating cooling water. During condensation, the working substance change its phase from vapor to liquid and reject its latent heat. The exhaust pressure in the condenser is maintained nearly 7 to 8 kilopascal, which is corresponds to condensate temperature of nearly 313 Kelvin. Now, what is the function of condenser? The function of condenser is to reduce the turbine exhaust pressure so as to increase the specific output and hence increase the plant efficiency and decrease the specific steam consumption. To condense the steam from the turbine and reuse it as pure feed water in the boiler. Thus, it make the less uses of the fresh water, only make of water which get lost due to evaporation is required to compensate. It enable removal of air and other non-condensable gases from steam, so it improve heat transfer. There are various elements of a condensing plant: condenser itself, air extraction pump, condensate extraction pump, cooling water circulating pump, hot well, cooling tower, makeup water pump, boiler feed water pump. These are main parts. It doesn't mean कि these are the only parts. इसके अलावा बहुत सारे parts हो सकते हैं. एक डायग्राम में हमने शो किया हुआ है विच शोज मेन एलिमेंट्स ऑफ स्टीम कंडेंसिंग पावर प्लांट. इफ यू कैन सी हियर, this is the condenser. See, condenser is a heat exchanger. We told you condenser is a heat exchanger. So from turbine, wet steam coming from the turbine here, and after rejecting its heat in the condenser, that collect here. Right? We are using a condensate extraction pump to remove the water from the condenser, and that hot water collect in the hot well, from where we can supply it to boiler with the help of a boiler feed pump. Right? This is a boiler. Then we are using an air extraction pump which remove the air in the condenser and supply the air to the atmosphere. I told you it is a heat exchanger. So how it is a heat exchanger? So friends, I told you condenser is a heat exchanger. So we are using water, cooling water, which is here. So this cooling water is supplied to the condenser, which remove the heat of the steam, and that cooling water supplied to cooling tower for cooling, so that we can use this water again and again. The water which get lost due to evaporated is completed by makeup water. Now, what are the advantage of friends? What are the advantage of condenser? See, it increase the work output per kilogram of the steam supplied to the power plant. It also reduce the specific steam consumption, so it reduce the size of power plant for the given capacity. It also improve the thermal efficiency of the thermal power plant. It affect the saving in cost of water to be supplied to the boiler since condensate is returned to boiler. Cost of water softening plants is also reduced because pure feed water is available for the boiler. If we are talking about classification in the condenser, there are two type of condenser. One is jet condenser, other is surface condenser. Jet condenser can be low level parallel flow, low level counter flow, high level jet condenser, and ejector jet condenser. While in case of surface condenser, it can be downflow, central flow, inverted flow, evaporative type, and regenerative type. Let we discuss about the jet condenser. In jet condenser, exhaust steam and cooling water comes in direct contact and mix together. Thus, final temperature of condensate and cooling water leaving the condensate is same. This type of condenser are generally used for small power plants, and when cooling water is very cheap and easily available, these condensers are not usually employed since condensate collected cannot be reused for the boiler because it contains some impurities like dust, oil, metal particles, salts, etc. in the condensate itself. Now let's say low level parallel flow jet condenser. See, in this case you can see this is a low level parallel flow. Why we are calling it low level? Because this height is very less, you can see. So exhaust steam enter from the top side and cooling water enter from the side wall through the pipe, and inside the condenser they come in contact with each other and they well mixed. So after getting mixed, they collect here from bottom. These can be removed. Exhaust system and cooling water both flow in same direction. Wet air pump is used to extract the mixture of condensate, air and coolant. This limits the vacuum created in the condenser up to 600 mm of HVAC. This is parallel flow. It can be counterflow. In case of counterflow, cooling water enters from the top side wall and hot exhaust system enter from the bottom side wall. So in this case also they come in direct contact. Now low level counter flow jet condenser. In case of low level counter flow jet condenser, you can see this is a low level counter flow jet condenser. In this case, cooling water enters from the top side and exhaust system enter from the bottom side. There are few baffles plates are there so that this steam cannot go direct outside. So when it comes with contact to the water, it release its heat and air is removed with the help of air extraction pump, and condensate collected at the bottom which can be removed with the help of a condensate extraction pump, right? The cooling water is supplied from the top of the condenser and steam from the side of the condenser. Already mentioned, the water flow in downward direction through a series of perforated trays. Steam gets condensed while it comes in contact with falling water. The air pump always maintains the required vacuum in the condenser and induce the cooling water to be lifted into the condenser up to a height of 5.5 meter. The excess amount of condensate from hot well flows into cooling pump by an overflow pipe. You can see this thing. Now we discuss high level jet condenser. See, high level jet condenser means the length of this pipe is more. The length of this pipe is more than barometric head, that is 10.33 meter. So the purpose of increasing the height of the water just to remove the condensate extraction pump which we used here. In case of low level jet condenser, we are using a condensate extraction pump to remove the condensate, while in case of high level jet condenser we are not using any pump. Water is coming down with the help of only gravity. So you can see the process is same whether it is a parallel flow or counter flow, right? This diagram is of counter flow where cooling water enters from the side top and exhaust system enter from the bottom side, and there are baffle plates, they come in direct contact, and an air extraction pump is there. Condenser shell is installed at height greater than that of atmospheric pressure in water column, that is 10.33 meter. A tall pipe more than 10.33 meter length is attached to bottom of condenser. This allows the condensate and coolant to be discharged from the condenser under gravity action. Hence, a condensate extraction pump is not required. The water from the hot well will not be able to rise into condenser and flood the turbine due to vacuum pressure maintained in the condenser. If we are talking about ejector condenser, then you can see the ejector condenser here. Cooling water enters from the top of the condenser under a head at least 6 meter of water pressure with the help of centrifugal pump, and then it passes over the series of convergent nozzle. See, you can see this is a series of convergent nozzle. Exhaust steam enters from the here, right? There is a non-return valve, so water and steam cannot go outside, they can only enter into the nozzle, into the system. The non-return valve helps in preventing the rush of water from hot well to the engine in case of cooling water supply fail. Now momentum of flowing water is responsible to create vacuum, right? And steam enters into the system. Due to that vacuum, the water and steam comes in direct contact, and after that there is a convergent divergent nozzle which increase the area, right? So and if here condensate and coolant can be removed without the use of any extraction pump. There are various advantage and disadvantage of that jet condenser. Advantage is that it is very much simple in design and cheaper and very less floor area is required, while disadvantage is that condensate cannot be used for boiler as this water is not pure. So if we want to use that water, we have to uh, treat this water, and very low vacuum efficiency is there. Next one is surface condenser. In case of surface condenser, exhaust system and coolant water does not come into physical contact. They are separated by heat transfer wall, so condensate remain pure and can be reused again and again. There is a diagram which shows a type of surface condenser. You can see in this case exhaust system enter from the top side while cooling water enters from the side. So cooling water is inside the pipe while exhaust system is outside the pipe. So cooling water move from this pipe to the shell to the pipes, and then it move outside while exhaust system comes in contact with the pipe. It release its heat, and it comes downward from where it can be removed. Next one is downflow surface condenser. In case of downflow surface condenser, you can see there is a diagram which shows the downflow surface condenser. Here we are using a nest of the pipes which can be honeycomb shape. So here there are various tubes. In the various tubes, water is passed through the tubes and exhaust system is outside the tubes. So here we are supplying exhaust system from the top side, and after releasing its heat, the condensate can be collected from the bottom, and air can be removed with the help of air extraction pump from the side of the wall. Exhaust system enter the top of condenser shell and flows downward over water tubes. Water tubes are double passed. The cold water flow in lower side first and then in upper side in the reverse direction, which enable the maximum heat transfer. Next one is central flow surface condenser. In case of central flow surface condenser, the steam flow radially inward. The condensate is collected at the bottom of the shell from where it is taken out by the condensate extraction pump. Here you can see there are a number of tubes in which water is circulating, and the exhaust system which enter from the top or side it radially move inside, right? When it comes in contact with the pipe, it releases its heat and steam convert into water, and that water collected at the bottom, which can be removed with the help of a condensate extraction pump. And in the center of the condenser there is an air extraction pump which remove the air. The steam get access to the entire periphery of the tubes, and thus a large surface area of the heat transfer is available as compared to downflow. Now, inverted flow condenser, the steam enters the bottom of the shell and air extraction pump connected to the top. Steam flow upward first and subsequently return to bottom of the condenser. The condensate extraction pump is connected at the bottom of the shell to extract the condensate. Next one is evaporative condenser. This type of condenser is used where there is a scarcity of the water, or water is available in very less quantity. In this case, steam is supplied through the pipe. You can see steam is inside the pipe, and water is supplied with the help of a pump, and water is sprayed with the help of nozzles. The nozzle comes in contact with the hot pipes, and few some water get evaporated, which can be removed with the help of a fan. There are few vapors which stop the loss of the water. Only air can allow, while the water droplets settle down at the sump, and which can reuse again and again and again. On few water particles leave the system with the air, so makeup water is used to to compensate that water. The evaporation of some cooling water provides the cooling effect, thereby steam condenses. Steam to be condensed is passed through grilled tube, and cooling water is sprayed over outer surface of the tubes. The evaporative condensers are most suitable for small plants where supply of cold water is limited. Now there are some advantages and disadvantages of the surface condenser. If we are talking about the advantages, there is very high vacuum efficiency. Condensate is in the purest form. Low quality cooling water can be used. It allows expansion of steam through a high pressure ratio. But there are some disadvantages also, that large amount of water is required for cooling the steam. Construction is complicated, it is very costly, maintenance is costly, skilled workers are required, and it needs large surface area. If we are comparing jet condenser and surface condenser, you can see there is a comparison that in case of jet condenser, cooling water and steam are mixed up, while in surface condenser they are separate. Jet condenser requires small floor space area, while surface condenser require more floor space. Jet condenser condensate cannot be used as feed water because it is not free from impurities, while the condensate in surface condenser can be used directly in the feed water because it is free from the impurities. More power is required for air pump in jet condenser as compared to surface condenser, while less power is required for water pump in jet condenser as compared to surface condenser. In jet condenser, less quantity of cooling water is required as compared to surface condenser. Jet condenser plant are very simple, while surface condenser plants are complicated. Jet condenser are less suitable for high capacity power plant due to low vacuum efficiency, while surface condenser are most suitable for higher capacity plant as vacuum efficiency is very higher. Now, vacuum creation in the condenser. When the steam condenses in a closed vessel, the vapor phase of working substance changes to liquid phase. Thus, its specific volume reduced to be more than 1000 times. Due to change in specific volume, absolute pressure in the condenser fall below atmospheric pressure, and a high vacuum is created. The minimum pressure that can be attained depend on the temperature of condensate and air present in the condenser. If now we are talking about cooling towers are natural draft and mechanical draft cooling tower. In case of mechanical draft, it can be forced draft. induced draft, and a combination of these two, that is known as balanced draft system. So first of all, we discuss natural draft cooling tower. Then we discuss forced draft cooling tower. Natural draft cooling tower is the shape of natural draft cooling tower is hyperbolic shape. Here you can see we are using some baffles or illuminated, which helps us to reduce the loss of the water due to evaporation. The height of this tower is very much. Hot water from the condenser is supplied through, it is sprayed here. Now the air which enters from the bottom side comes in contact with this hot water and moves upward. Right, there are eliminators which help to reduce the water losses. And from the bottom there is a pond from where we can supply the water for cooling in condenser. Natural draft cooling tower operates on the stack effect which cause the hot air in the tower to rise. Wet natural draft cooling tower are used for electrical energy industry but can be used for other industrial object also. Such towers allow the cooling of high water volume and are designed both from concrete and metal structure. Advantages of using natural tower that almost no power consumption to induced airflow, no fan required, so there is a saving in the power. It is environmental friendly, no mechanical loss as there is no fan. There is a safety of operations, no recirculation as prime as the plum is rejected at high level. Limited plot area is required. Limited maintenance. Payback period between 8 and 16 years depending on few factors. While disadvantage is very high investment, initial cost is very high. Large overall dimension that could cause difficulties with area aesthetic and requirement of large areas for tower installation, and height is very much which can sometimes be obstructions for the aeroplanes or helicopters or for defense purpose. That's why when there is a restriction, then we are going to mechanical draft cooling tower. In case of mechanical draft cooling tower, height is very less, but here we are using fan. So mechanical draft cooling tower are very much similar to natural draft cooling tower, but here air is circulated inside the tower mechanically instead of natural circulation. Propeller fans or centrifugal fans may be used. You can say in this case, we are using a fan which supply the air, right? So it can be forced draft, it can be induced draft, it can be balanced draft. Advantage is for the same capacity used, the mechanical draft cooling tower are much smaller than the natural draft cooling tower. This is because of the increase in cooling capacity due to increase in volume of the air being forced out by fan. Capacity control is possible in mechanical draft cooling tower. By controlling the speed of the fan, the volume of air can be controlled easily, which in turn control the capacity. As they do not depend on atmospheric pressure, so mechanical draft cooling tower can be located even inside the building. Disadvantages is that they require more power to run the system. It increases running costs due to increase in maintenance of the fan, motor, and its associated controls. Induced draft cooling tower. In case of induced draft cooling tower, we are using a fan at the top of the cooling tower. A mechanical draft tower with a fan at discharge which pull air or which induced the vacuum. The fan induced hot moist air outside the discharge. This produces low entering and high exiting air velocity, reducing the possibility of recirculation in which discharge air flows back into the air intake. This fan or fin arrangement is also known as draw through cooling tower. Induced draft can be of cross flow. You can say in this case induced tower cross flow. There are baffles in the V shape which eliminate the water. Right, water is spray here, air is moving in this direction. In the cross flow cooling tower system, the water vertically flows through the fill media while air horizontally flows across the falling water. That's why they call it cross flow, because the air and water cross path or flows. Because of the crossing of flow, the air does not need to pass through the distribution system. This permits the use of hot water flow via gravity and distribution basins on the top of the tower right above the fill media. Right. You can say comparison between natural draft and forced draft cooling tower. If we are talking about size and shape, natural draft cooling tower may be 125-meter high and 100-meter in diameter and hyperbolic shape, while for the same capacity forced draft cooling tower may be 15-meter high and 1000 of meter in length, has long rectangular box shape. Initial cost of natural draft cooling tower is high, while for the mechanical cooling tower is almost half. Operating cost is less, it is high, it is maintenance cost is low, it is very high. Water loss is less, where it is more. Life is more, where life is less. Now, cooling tower. Cooling pond. A cooling pond is a man-made body of water primarily formed for the purpose of supplying cooling water to a nearby power plant. Cooling pond are used where sufficient land is available. It is an alternative of cooling towers. Cooling pond is one of the simple method of cooling the condenser water plant. This method is less efficient than cooling tower, but it can be used where the soil capacity is not good, where we cannot erect cooling tower due to soil bearing capacity. So types, there can be three types of cooling pond: natural and directed flow cooling pond, single deck or double deck cooling pond, and spray pond with lower fans. You can say natural flow cooling pond. That in natural flow cooling pond, we are supplying hot water from the condensate, and when this hot water get cooled, due to density difference, the cold water settle down, and from the bottom side we remove the cooled water. This figure shows a non-directed flow natural cooling pond. In natural flow system, water is coming out from the condenser, is just allowed to flow inside the pond. This system is rarely used nowadays, but here we are using a directed flow cooling pond. In case of directed flow cooling pond, you can say that hot water is supplied from the here. This can be of metallic, or these plates are of metallic. Hot water supplied from the here. This hot water distributed in two side, and then this flow is directed. These plates are mostly of metal, so that they can release its so that water can release its heat, and cold water can be collected from here. In directed flow system, the hot water coming out of condenser enters the middle channel as shown in figure on reaching the far end, divides into two current being directly by baffles valve so as to traverse the pond several times before uniting at the intake point. The water gets more time and passes over a more surface, so cooling achieved is very much effective. Single deck spray pond, in this case there is a cooling pond. This is a cooling pond, and we are using a pipe in which we are using some nozzles. So this hot water coming out of the nozzles, and all the nozzles at the same height in a single deck arranged in the same elevation as shown. Its effective cooling system is less than double deck system. In this system, warm water it received from condenser uh, spray through the nozzles over a pond of large area, and cooling effect is lost by evaporation and windage. While there is a double deck spray, in this case, you can say there is a pipe which carry hot water, and all the nozzles are adjusted at two different elevations. You can see one is this elevation, other is this elevation. So in this system, spray nozzles are arranged at a different elevation as shown in figure. Its cooling effect is more than single deck system, as water comes in contact with air at lower temperature. Now, spray pond with Lawrence fans. See, there are nozzles, and here we are using, you can see we are using fans so that evaporation loss can be minimized. In case of open pond, the draft loss will be more if wind velocity is high. This can be avoided by providing lower fans as shown in figure. Now, what are the advantages and disadvantages of the cooling pond? Initial cost is very less and very much simple in design and arrangement. But disadvantages is that it required large area for cooling, more amount of loss of water due to evaporation and windage, very low cooling efficiency, and there is no control over the temperature of cooled water. So friend, this is all about the condenser, cooling tower and cooling ponds. Thank you very much for listening. Thank you.